All right, so here's problem number 4.5, number 18. It's the one about the rock climber. So it gives you a drawing that looks like this. You got this little, they call it a chimney, a little rock chimney with this climber in here. So here's our climber. Hello. And then they've got, a broken leg apparently. Whatever, we're going to leave it. Their legs are like that, and she's kind of sitting like this, right? Okay. So it tells us that the climber has a mass of 49 kilograms. And it tells us that the coefficient of static friction between her shoes and the rock, so on this side, the coefficient of static friction is 1.2. And then it tells us that the coefficient of static friction between her back and the rock is 0.8. Okay? So, let's think about what forces there are here. Okay? Well, so first of all, there's going to be gravity, right? Gravity's going to pull her down with a force of mg, right? Okay? Now, what she's doing, presumably, she's using her feet, and her feet are pushing the wall, and her feet are pushing the wall this way, right? But that's not a force on her. What is a force on her is the reaction to that, which is the wall pushes her feet this way with some amount of force, which we'll call Fn, right? Okay? Well, so why doesn't she move that way? Oh, well, it's because her back is squished against this other wall, and the other wall is pushing her this way with that same amount of force, right? Notice those two normal forces are equal and opposite, right? Okay, the wall is pushing her feet to the right with X amount of force, and the other wall is pushing her back to the left with that same amount of force, right? Okay. And then finally, there are two frictional forces. There's the force of static friction from her back, and there's also the force of static friction from her shoes, okay? Now it tells you she's just on the verge of slipping, so these are both the max, right? Okay? So, let's do this. We know she's just on the verge of slipping, so we can go back to our net force equals net force thing, right? So, mass times acceleration equals the sum of all of our forces, which for us, we don't need to worry about the two normal forces because they cancel. So then we've got gravity plus the force of friction static from her shoes plus the force of friction static from her back. Okay? And the goal is we want the acceleration to be 0. And then our forces of static friction are the max, right? So this one is going to be 1.2 times the normal force. And this one is going to be 0.8 times the normal force. So you get 0 equals negative mg plus 1.2 Fn plus 0.8 Fn is 2.0 Fn. So you get mg equals 2 Fn, which means Fn is, half of the weight, right? Okay, and I think that was all we needed to do, right, was find that normal force. Yeah. So if you solve that, it ends up giving you 240.1. Okay. And then C says, what fraction of her weight is supported by the frictional force on her shoes? Well, just find this force of static friction and divide it by her weight, and you get 60%, or you get 0.6, I guess, which is 60%. Okay, so that's the deal there.